Hey everybody, this is Mr. McKee again with CIS 115, IoT connecting things. Today I'm going to be going over lab 2.2.2.5, which is blinking an LED using the breadboard and Arduino IDE. All right, that's me right there, working on my little, it looks like an old Apple computer. No, that's not me. But usually they say use a breadboard, but I've actually got a Metro board, which you can see on my cam on the right hand side of the screen. And I'm going to download the Arduino IDE and show you guys how to do that. All right. Also, I have a USB B that's from an old charger from a Android phone to power the Metro board. All right. And there's some differences here between this and the breadboard, but I'll show you guys exactly what's the differences are. All right. So Arduino, which is open source hardware prototyping platform, started the revolution in the maker community. Access to electronics control and programming has dramatically simplified and revolutionized how smart devices are built. In this lab, you will learn to use the Arduino and Arduino IDE to make an LED blink. Inside of the SparkFun Inventors Kit, you will find the resources needed to start to prototype smart things. The Arduino compatible breadboard is able to read inputs, a light on a sensor, a finger on a button, or a Twitter message, and turn it into an output, activating a motor, turning on an LED, or publishing something online. And this is defined by a set of instructions programmed through the Arduino software, which is the Arduino IDE. All right, so we need a PC with internet access, SparkFun Inventors Kit, or compatible Arduino kit, which I made my own kits. But due to what's happening right now with all the stuff going around, Adafruit was one of those companies in New York City that had to shut down everything. So we're kind of behind on getting some of our kits together, but we have enough just for me to trial it and show you guys how it's supposed to work. All right. And we need a breadboard, LED, 330 ohm resistor, and wires. All right, so first thing we're going to do is installing the Arduino IDE. So navigate to arduino.cc and that link right there in your web browser, download and install the Arduino IDE software package. The software package contains the integrated development environment as well as required drivers for the Arduino boards. All right. So if I do control click on that, all right, you'll notice, and we want to go, this is the current version 1.8.12. All right, for what I'm doing, you can click the Windows app and download that if you have Windows 8.1 or 10. I'm just going to download the Windows installer. So if I click right there, you can contribute to Arduino software, but I'm just going to click just download, and I'm going to save that. And I'm just going to wait until that's done. All right. So I'm going to go ahead and run it. And let's see if all right. Agree to the license agreement. All right, I'm going to install everything that's checked. Install it right there. Space required 535 megabytes. I have 15.7 gigabytes, so I'm good. It's going to take a little bit time to download that. It does have instructions if you're using a Linux distribution like Debian, things like that. So it's about done. And while I'm waiting for that to do its thing, I'm going to go ahead and show you guys on this Metro board. There's your USB B plug-in right there. It's just an old charger plug. All right, B. Looks like a little trapezoid, so I'm gonna plug that in. I'm just gonna wait until it's done installing. And this does come with some little feet you can put on here because you don't want to ground this out on any metal. All those pins. There's your little feet you can put on there. I'm doing this on a piece of paper, so it's all right in my case. And I've got little cases for these too. But since everything didn't come in, I couldn't really do it the way I wanted to do it. All right. So now we're going to go ahead and do step 2, which is connecting the red board to the computer. So I'm going to plug this in one of my UPS or USB ports. All right. You notice I do have power. The little LED light comes on. You guys can hardly see that, but you can barely see it, but where it has on right there, there's an LED, green LED, indicating that it's powered up. All right. So use the USB cable that is included with the SparkFun Inventor's Kit to connect the red board to the PC. The first time this is done, you should see Windows installing the device driver for the board. You don't see that because I actually tried this. I've already done this lab a couple times. All right. So using Windows Device Manager, verify that the board has successfully installed as a serial COM port. You can start Windows Device Manager by going to Start Run, or do WinR and then enter the device manager.msc. So I can do dev, and as soon as I type in dev, device manager is right there, so that's a quicker way to do it. All right, scroll down, ports. All right, see right here, Silicon Labs CP210X. All right, I'm on COM6. That's my Arduino Metro board, Arduino compatible Adafruit Metro board. All right, so just remember that. All right, so it says record the COM port of the Arduino board for future reference. In this example, they had COM4, we have COM6. All right. All right, so from the start menu, start the Arduino IDE, and that's my very first top selection of my start. All right, so we got to set the COM port. If we go to Tools, and see, at first this wouldn't be selected more than likely, but just select COM6. All right. All right, some different directions if you're a Linux user. All right, what we want to do first is actually configure it where it's going to make the board LED blink. So from the File menu, select the example sketch, source code of your program for blinking an LED. So go to Examples, File, Examples, Basics, and then Blink. All right. So this is that was just a blank program right there. All right. Just make this a little bit bigger. And there's two functions in here. The setup function runs once when you start, reset, or power the board. All right, setup. And these are just comments. Initialize digital pin LED built in as an output. So we come through here and we'll get into this later, but that's where you put your LED, which LED pin you're using, or our GPIO pin. And then down here, the loop function runs over and over and over again forever. And here's a function which is just going to loop. And LED underscore built in, you're going to change that with your whatever pin you're using. All right, so high means it's actually gone up to full power, which is 5 volts. And then you'll put down here digital write LED built in. You'll change that also to your pin in our cases, which is going to be 13. And then if set to low, it tells you right here, turn the LED off by making the voltage low. And then this delay is 1,000 milliseconds, which is 1 second. All right, and that just says wait for a second. So these are all comments. Anything with double forward slashes, everything to the right of that is a comment. All right, so comments up here, bunch of comments up here about who wrote this. All right, function, and then whatever it's doing. Digital write, it's actually writing, putting output on the pin or voltage on the pin there and turning voltage off the pin there. All right, so pretty simple. So let's get into this thing. All right. So note the syntax of the Arduino language used to write sketches is based on C and C++. If you're familiar with C, C++, JavaScript, or PHP, you should be able to quickly catch up. Even if you have no previous experience, the code is pretty self-explanatory. A complete language reference could be found at this link. All right, in case you need that. In the blank sketch, examine the setup function using pin 13 as an output pin. All right, this requires the use of the pin mode pin value. All right, so what we're going to do is initialize digital pin, and you can put 13 here if you want. That's just a comment, but the actual change is going to be right here. Your pin mode 13, you're telling it 13 is going to be an output pin. All right. In lines beginning with double forward slashes, like I said, above indicate comments to help describe what is being done and ignored by the Arduino board. Pin 13 is special as it has an LED attached directly on the red board. Now, one difference on the Metro board, and I wish I had a, here I'm going to point with my digital meter, but let me move this. All right, instead of the red board has a LED right here, right beside pin 13. This board has an L and has a little LED right here, right beside the USB plug. All right, so that's going to light up red. Red when it's on, and then it's going to go off when it goes to low or turned off. All right, so you can just use it to test your program if you need to. All right, so predict the output of the loop function. The digital write function sets the value of pin 13 to high. A delay function will then pause the execution for 1,000 milliseconds. The next use of digital write function will set the pin 13 to low, followed by another delay of 1,000 milliseconds. Upon completion of the loop function, the loop function executes again. So it's just a infinite loop. The loop will repeat until the red board is turned off. And right here, it actually shows you what it's going to do. All right. So what we need, only we need to change really. Let me get back to my IDE. All right. So it has LED built in. I'm just going to change that to 13 because up here, it's my pin 13 is going to be output. All right. And then change that right there to 13. All right. So there's our changes. We can verify everything's right. All right. Verify and compile the sketch to create an executable firmware that can be uploaded to the flash memory of the microcontroller. All right, so to verify and compile it, click that. There's your status. All right, done compiling. Tells you some messages down there. All right, status messages. And then upload the firmware to your Redboard. So upload is right here, a little, looks like fast forward button, I guess. All right, done uploading. All right, and after this step, you should see the onboard LED connected to pin 13 blinking in a 1-second interval. All right. So if you look at my board, instead of a LED beside pin 13, which is right there, I've got a LED blinking right here. So on for 1 second, off for one, or yeah, on for 1 second, off for 1 second, on for 1 second, forever. All right. So how can you change the blinking rate? You guys should be able to figure that out by what we did. If nothing else, look up here and kind of like try to figure it out. All right, so part 2, connect an external LED using a breadboard. Now, I'm not going to use a breadboard. I'm going to use the circuit that I made for the last lab we did earlier today. All right, so identify the GPIO pins and the analog input pins on the following picture of the breadboard. All right, so these are digital. There's analog pins down here, power pins down here. All right, our board is pretty much the same. Some of the things are in different locations, but it's pretty much the same. Ours has a switch right here too that turns this older power plug on and off. We do have a reset button. Everything else looks about the same. Looks like the processor's turned sideways, but yeah, it's compatible. All right. So connect an external LED using the breadboard to the Arduino. Using an LED, jumper cables, and a breadboard, connect the breadboard to the LED. The logical schematic is outlined in the figure below. The LED will be connected to GPIO pin number 3. It is very important to connect the 5-volt cable to the breadboard last. Connecting the power to the breadboard at any other time may result in damage or destruction to the Arduino board. All right, and this is basically what we're doing. We're connecting in right there. Have an LED, anode side, cathode side, resistors right here on the ground side. All right. So the LED has 2 legs. One is called the anode, which is the positive, while the other is the cathode. To light up the LED, charge the anode to about 2 volts and the anode to ground. The anode leg is generally longer than the cathode leg, but it is not a standard. On the other hand, the cathode leg is always connected to the bigger part inside the LED. So if you actually can look in the LED, you can tell that this side's bigger. All right. The resistor which is serially connected to the cathode side of the LED, is used to prevent too high of a current from flowing through the circuit. An LED requires about 15 milliamps of current and 2 volts to light up. The breadboard provides 5 volts on each GPIO pin. Directly connecting the LED could result in burning the LED out, or it'll like pop because of the high voltage and resulting current, or in some situations even damaging the breadboard. All right, so search for a 330 ohm resistor in the SparkFun Inventor's Kit. Connect the LED, resistor, and jumper cables as shown in the physical diagram above to a breadboard, and to a breadboard. The physical connections are outlined in the figure below. All right, so this is the positive side on pin 3. Jumpers over here. All these pins are connected together internally inside the breadboard. All right, so it goes this way, goes to the LED back, touches right here, jumps over through the resistor, and then this is connected internally to that jumper, and then that jumper is going to ground. All right. So what this is controlling is the 5-volt output of pin 3. All right, running the software. Update the previous blank sketch code in the Arduino IDE to blank the LED on the GPIO pin number 3. All right, and it's best to do that. Let's go ahead and look at my, in case you guys didn't watch my other video. All right, there's my LED. This is the anode side. This is the cathode side. 330 ohm resistor connected to my black wire. All right, so that's the negative side. So if I go to this, has to go to ground, so there's a ground right there, and there is a ground right here. Where's it at? So I'm going to go to ground right there. All right, ground, and pin 3 is going to be my positive. 1, 2, 3, 4. All right, I'm going to ignore that call. All right, so the LED is not lit up. Just make sure you're in ground with the black, in number 3 with the positive. All right, what I'm going to do is I'm going to go back to my IDE, and what I'm going to do is change the pin number to make 3 an output, and then down here change this to 3 for digital write for high, this for digital write for low. All right, now that I've done this, I need to compile it first by clicking verify, the check mark. All right, done compiling, and then actually flash it to my my Metro board. All right, done uploading. All right, so if you notice, once I did that, the light started blinking. And if you guys can see that, all right. And that's 1 second on, 1 second off. If I wanted to change that, I'm not going to tell you guys how to do it, but I'm going to show you guys. All right, so if I made let's see what this does. All right, done compiling, upload it. All right, you notice once it flashed onto the memory of the Arduino board, it's flashing every 1/10 of a second now. So 10 milliseconds is a 1/10 of a second. All right, if I wanted to go back, and this is how long it stays lit, this is how long it stays off. So I guess you'd always, pretty much always make those the same. All right, so if I did this again and uploaded it, it'll go back to second on, second off. All right, so you've written your first program. All right. All right, so reflection, what issues could cause the failure of the LED to blink? All right, there can be numerous things. Some of them I could tell you would be, bad connections. This could be wired backwards because electrons can only flow in that circuit one way with that LED in there. All right. And also, if you didn't put that resistor on there, it would blow that LED up, and it wouldn't work anymore. All right, so that's about it. Thanks for watching, and I'll go ahead and make another video of, I know this is really basic, but we'll be getting into more using the Arduino boards with Raspberry Pis. All right, thanks for watching.